David Smith here with another flipped classroom math lesson. 3 tips before we start. First, you can adjust the playback speed if that helps you get through the video. Second, you can pause the video at any point to take notes or work the examples. Third, you can turn on the captions and read my words go by on the screen. All right, let's do some trigonometry review. Woohoo! Okay, so in this little chapter, the first thing we did was SOH CAH TOA trigonometry. So this is the basic trigonometry that works for right triangles only. Okay, so these triangles have adjacent or opposite and a hypotenuse. So remember, we do some of the later rules, sine rule, cosine rule, area of a triangle. There's no hypotenuse, no adjacent, no opposite. But we started with SOH CAH TOA. So to review, SOH CAH TOA is a cool tool that helps you remember what the ratios are. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if you can memorize this, which I think you can, then you know what each of the 3 trig ratios are. Okay, I'm going to do 2 problems. We used SOH CAH TOA to do 2 things. Find a side in a right triangle and find an angle in a right triangle. So let's get started. Here's my triangle. Right angle there. You know that one's 41 degrees. You know this side is 27. You're asked to find x. So what you do is you position yourself in the triangle where the angle is. You look out into the triangle and you try to figure out what you got. And so in this case, we're looking across. X is opposite. Remember, this one is adjacent because it touches the angle we have. So x is opposite. 27 is the hypotenuse because it's opposite of the right angle. This is always going to be the hypotenuse. So, which function uses opposite and hypotenuse? That would be sine. Sine equals opposite over hypotenuse. So now I can write my equation. Sine 41 degrees equals opposite, which is x over hypotenuse. On a quiz or a test, show me this step. That's half the points for a problem like this. If you skip this step and just start punching buttons on your calculator and you get it wrong, I can't give you any partial credit. Okay? All right, so now we solved this. And we also had a nice little memory trick for a quick way to know what to do next. When the variable's up high, you multiply these 2. Okay? So x is going to be 27 times sine 41. And just know, I don't get out my calculator first and then write down that decimal. I leave it like this because then when I get my calculator out, I don't have to round sine 41. I can just do all the math and round at the end. Action. Okay, now I have my calculator and I can just punch this in. 27 times 41 sine equals 17.7. So this side is 17.7. Now, there's a step you can do now. Is this answer reasonable for the diagram? And yeah, I think it is. If that's 27, it makes sense that that could be 17.7. It's shorter, but not a whole lot shorter, so that makes sense. Do a reasonableness check. If I got like 325, something's wrong, because there's no way x could be 325. All right, let's move on. Finding an angle. So this is just what we call inverse trigonometry, or maybe better yet, inverse SOH CAH TOA. So let's check this out. Theta is the angle we don't know. So we're going to find theta. The rest of this is kind of the same. Put yourself in your angle and look out into your triangle and figure out what you have. So from theta, this side is adjacent and this side is the hypotenuse. So we have adjacent and hypotenuse. So which function is that? That would be cosine. Cosine is adjacent over hypotenuse. So now I can write this equation. Cosine theta equals 8 over 9. So again, that's worth half the points for a problem like this. So now we have to do this little trick to do inverse trigonometry. I don't know what theta is, so I can't just plug that in. Now I notice I don't have an unknown here. This ratio, 8 over 9, is completely known. So what we do is we do backwards cosine or inverse cosine, and it looks like this. Cosine inverse. That's not the -1 power. It looks like that, but this is notation. So this is inverse cosine of 8 over 9 equals theta. Okay? So now I just get out my calculator and I do that. And on my calculator, I do 8 divided by 9 equals, and then I hit the second function for inverse cosine, and it's going to spit out 27.3 degrees. So theta equals 27.3. Now let's take a look. Is that reasonable? Yeah, it makes sense. This has got to be a pretty small angle. Certainly can't be 45. It's got to be less than that. So yeah, 27.3 makes sense. Now a final word before we move on to the more complicated problems. Know your calculator. I use a very simple scientific calculator that allows me to enter these things in nice and quick and easy. If you have a more complicated calculator, that's fine. But by the time you sit for a test, you should know how to do the calculator nice and quick and easy without mistakes. A real recipe for having problems is to buy a new calculator and use it for the first time on a test. That's kind of asking for trouble. Okay, the next lesson we covered in this chapter was the triangle area formula using sine. Okay, so this is closely related to the general triangle area formula, but it lets us do this without knowing the height. Like on a triangle like this, the height's not readily apparent. It's going to be some vertical line going from a corner perpendicular to the opposite side, but we don't have that. So this formula is really handy when you don't have that. A quick reminder, when you label this triangle A, B, C, big letters, the little letters denote the side opposite of the angle. So big angle A is opposite of the side of little a. B is opposite B, C is opposite C. So you want to make sure you do that because this rule and the two that follow relate to this diagram of a triangle. And remember, no right angle here. There's no hypotenuse in this triangle, and as such, there's no adjacent and opposite sides either. This is not SOH CAH TOA trigonometry. Okay, so the formula for the triangle ABC is just going to be 1/2 times 2 sides times the sine of the angle between them. So in this case, it would be 1/2 times these 2 sides times the sine of the angle between the 2 sides. So that's a super important thing to realize. So here's a simple problem. I've got my 2 sides and my angle that's between them. So I want to find the area. So area is 1/2 times 31 times 49 times the sine of 57. And remember, show me this plug-in step. Let's get out the calculator and do the math. 0.5 times 31 times 49 times 57 sine equals, I get 636.97, so I'm going to round that to 637.0 equals 637.0. Hi there. Okay, the next thing we did was the sine rule. Again, another trigonometry rule that works on triangles that don't have right angles. It does work on right triangles as well, but that's not primarily where we use it. So the way that works is it starts with the same diagram with the big ABCs and then the little letters opposite their uppercase counterpoint. So there's your triangle that helps you orient it. The rule is pretty simple. Side A over the sine of angle A is the same ratio, is equal to side B over sine B, which is also equal to side C over sine of angle C. Pretty straightforward ratio. I watch you guys doing it in class. People seem to get it pretty quick. So let's just do one problem. Here's a triangle. I want you to find x. Notice how we gave you all the angles you need. X is across from 48. You know 12, and it's across from 88. So we can set up our ratio. X over sine 48 is going to equal 12 over sine 88. Now I'm going to solve for this by cross-multiplying up first and get sine 48 times 12 over sine 88. Action. So given the way I wrote this, you want to make sure you don't do one thing. This is not the sine of 48 times 12. That will give you a bad result. You want to do sine 48, then multiply that result by 12. It's a different thing. Okay, so now I can pull out my calculator and just do this in one calculator step. I'm going to do 48 sine times 12, just like I said. And then I'm going to divide it by 88 sine to get 8.92. So that's going to round to 8.9. Do a reasonableness check. If this is 12, could that be 8.9? Yeah, that seems about right. That could be 8.9. Okay, let's do the cosine rule. This is by far the most complicated of the three non-right triangle trigonometry rules that we covered in this particular chapter. So let's dig in here. Cosine rule uses the same diagram we've been talking about all video long, so I'm not going to review that. Here's the cosine rule. A squared is going to be b squared plus c squared minus 2bc times cosine A. And here's one of the things I remember about setting it up. A squared, which is a side, is going to be all the way opposite cosine angle A on the other end of the equation. So as long as you do that right, then the other two sides fall into place and you should be good to go. So let's take a look here. Here is my triangle. Here's the problem. So try a plug-in step. See if you can set that equation up right. When you got your plug-in step done, then come back. Okay, check this out. X is our A. This is what we're trying to find. So I'm going to write x squared equals, now all of this is just the other two sides. So I'm going to go equals 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of angle A, which is 31. So hopefully you got that right. Now go ahead and simplify this down, find out what x is. Okay, let's see how you did. So x squared is going to equal 36 plus 16 minus 2 times 6 is 12 times 4 is 24 cosine 31. X squared, let's take care of this. 36 plus 16 is 52 minus 24 cosine 31. So now it's all ready for me to do a calculator step and solve this equation. 52 minus 24 times 31 cosine equals 31.42 decimal goes on. I'm not going to write that down. I'm just going to take the square root of it so I can find x. Square root gives me 5.606, which is 5.61. And there you go. Let's do a reasonableness check. If that's 6 and that's 4, does it make sense that that could be 5.61? Yeah, that seems about right. It's bigger than 4 and less than 6, and yeah, that looks right. Okay, if you recall from the lesson video that we did with the cosine rule, we also used it to find angles. And here's the formula that we used for that. So angle A, that's the degree measure of angle A, is the inverse cosine of that. And all this is it's the two sides that are not opposite angle A, square them, add them together, and then subtract the square of the side that is opposite of angle A. And this is all over 2 times B times C. So this expression, taking the inverse cosine of it, gives you angle A. And so check it out. All sides, there's no angles in there. So you can use this rule to find any angle in a triangle when, for example, in this one, you know all 3 sides. Okay? So here we go. Find theta. That's the instruction. So here's what we do. We write theta equals the inverse cosine of, now if you're feeling bold, pause the video right now and see if you can get a correct plug-in step. Okay, so here's the side opposite of the angle. So that's going to be at the end. That's going to be minus 10.6 squared. The other two sides are going to come closer. That's going to be 12 squared plus 5.3 squared. So that's the top. And then the bottom is just going to be 2 times 12 times 5.3. Okay, so pretty straightforward. Make sure you get this right. Make sure you show that to me. This is a really important step for partial credit. Okay, now I think I can do this all with one session on my calculator. I'm going to calculate the top of this. I'm going to do 12 squared plus 5.3 squared minus 10.6 squared equals, and then I can just divide it by each of these three numbers in turn. I don't have to actually multiply them. I can just divide what I have now. So divide by 2, divide by 12, divide by 5.3, and I get theta equals cosine inverse of this big old decimal. I'm going to do 0.4696. It rounds to that. But here's what I'm going to do. I'm not even going to round it because I have that on my calculator right now. So all I need to do is click second function cosine, and I have my answer. 61.99 degrees. So that gives me a theta of 70.0 degrees. Now, reasonableness check. That angle, is that 70? Well, yeah, I think it's probably close. There's a 90. It looks bigger than 45, so that could be 70. Lastly, you're going to be expected to do some problem solving using all the rules and laws that you saw in this chapter. So basic SOH CAH TOA problem solving, you had a whole activity on that. And then we can also do problem solving with the area formula for a triangle, with the cosine rule and the sine rule. And I'll give you a tip. You should also be able to find angles with the sine rule. We didn't have a lesson on that, but you should be able to use your understanding of how trigonometry works and how inverse trigonometry lets you find angles. You should be able to do that with the sine rule, and that's a hint. Otherwise, when you look at a word problem, make sure you draw a diagram. Geometry is visual, so if you draw the triangle, draw the things, mark the angles, mark the unknowns, then once you have that diagram in front of you, then it's easy to see which law applies and how to use it. So work on that carefully. Now that you've watched the video, jot down a few extra notes or questions for our next class. You can also re-watch portions of the video that you didn't understand the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.